Hello and welcome to this short introductory video on how to create live Excel plots during your Genesis optimization solves using the Lua script functionality. So I'll just take you through an example here. This is one of our tutorials for OptiAssist, and what we'd like to do is, when running an optimization that does take some time, maybe one that takes a few hours to run, it's useful to monitor the progress of that graphically. And sometimes we want to monitor responses and how they are all behaving relative to the constraints that we have defined. So here, what we'd like to do in this example is monitor the mass, which is the objective. That's quite a nice straightforward one. But additionally, in this model, we've got two displacement constraints, one here at the front and one here at the rear. And what we'd like to do is monitor those through the optimization and see how close they become to our constraints, which is 10 millimeters for each point. So the way we do this is we can introduce a Lua script, and there's a template available for you, which I will inform you how to get at the end of this video. And what we do is we can add that inside Design Studio or reference it with an include statement, but I'll show you how to do it today in the Design Studio interface. So what we want to do first of all is we need to identify the response IDs that we want to consider. So that would be these two displacements and the mass objective. Now that's not immediately visible inside Design Studio, but no problem, we can easily find that inside the input file. Now if you're solving directly from Design Studio and you don't want to go or you're not familiar with how to export and manage this, an easy check just to do is to just perform a check data run. That's going to create you the input file without going through the solve, and that will allow us to then interrogate the file. So I've done that, and the file that's being created is here. So this is my example. So what I need to do is just search for DRESPs, and you can see here what I've got in my model is DRESP ID 28 is my mass, and if I scroll a little further, I've got my forward displacement and my rear displacement are 29 and 30. So we've got those three IDs that we want to consider. So next we have our Lua script. Let's say this is something that you can obtain from our support team, and I'll pop up the email address at the end of the video. And it'll be this data here that we just want to edit specifically for our run. The rest of it is all consistent with for every single run. So we can just copy all the data, pick it all and copy, and then we can return to Design Studio. And the option to add this functionality is here, so I can go to Genesis Options, and noting I've gone to the Design tab, I can choose a control script. And if you're not familiar with this scripting, this is a very powerful function inside Genesis where you can do an awful lot of additional functions. So you can add reporting here. There's many scripts available we can assist with for helping with your post-processing, or even controlling the optimization in some way. This is a very powerful part of Genesis. So here what we've got is the script that is going to create the Excel data. And all we need to do is have one of these lines for each of the responses that we want to monitor. So here I'm going to choose 28, I'll define 29 and 30. And I can just give them a label that's going to appear in Excel. And we would call this forward disp, and this one rear disp. Okay, and what is referred to here is we have an option to do load case equals, so you can have it specifically for a load case, or you can leave it blank for all. And then here we've got nothing because mass is independent of load case, so we don't need it. The other option we've got is this side option of min or max, and that's for responses when there are more than one value in the response. So in displacement of a single node, it's only one, but if you had selected several nodes in that constraint, choosing max will give you the maximum value of all the nodes within that response type. Okay, so that's a similar approach for failure index, for stress, or other such multiple output responses. So that's all you need to do to edit the output, and then choose apply, and next we can run it and I can show you what we get. I choose to optimize that. Okay. So as the job is running, we can just navigate to the folder. So if you are running this on a separate cluster, you can easily retrieve this file. So what you'll find is there'll be a file created called history, or called the input file name _resp_his.xls. Okay, so that is going to be created every cycle of your optimization. So you can retrieve that from your cluster whilst it's running and take a look at it. And equally, you can just load it directly here. So I'll just check my job has finished. Okay, so just a short tip as well while I'm at it, rather than running till the end. I can see that's converged that I'm happy with, so I'm going to clean stop that. Okay. So then all we need to do is load this plot. And here we can see what we have. So on the first sheet, we're going to have the histories plotted directly. So this is for each cycle. We have the mass, the forward displacement and rear displacement. There'll then be a second sheet, which is the chart for all the responses that are together. Now, as you can see in this case, mass and displacement don't really fit on the same graph. So what you also have is the ability here to have each of the individual charts added. So you can see mass as the objective is plotted, one for forward displacement and one for rear displacement. And so what's useful is if this model is running and you've looked at this during the optimization, so you've taken these files from your cluster, is you can see very clearly here that the rear displacement is at 10 millimeters, exactly on the limit. But the forward displacement is very much converging around about 7 millimeters. So even though the constraint is 10 millimeters, you can really see that it only goes as far as 7. And that's really quite useful information to know which of the responses is driving your optimization. So if it is something that you can control or can have some tolerance on, you can choose to relax it or not to improve your solution. Okay, so that is the process as mentioned. So the template for the Lua script that you'll need is something we can send you from the support team. So you should have the email address appearing on screen now, and if you email support@grm-consulting.co.uk, as you can see here, and just request the Lua script for history plotting, we can send that right away to you. Okay, thank you for watching. Bye-bye.